Hello everyone, and you see that my lips is so big one side and and because we had two problem here. But anyway, today we keep going to speaking English and let's get started. Good evening everyone, and welcome to day 9 of my 30-day English speaking challenge. Today I'm going to explain the injection molding process in a clear and professional way. This is one of the most important manufacturing technologies in the automotive industry, and understanding it helps customers and new engineers better visualize how plastic parts are produced. So, injection molding is a manufacturing process used to produce plastic parts in large volume with high accuracy and repeatability. The process involves melting plastic material, injecting it into a mold, cooling it down, and then injecting the final part. It is widely used to it for interior and exterior automotive components, electronic housing, and many consumer products. The injection molding system consists of several key parts: the hopper, the screw, the barrel, the mold, the clamping unit, and the cooling system. The raw material is packed into the hopper, then heated and transported through the barrel by the rotating screw. The mold defines the product's shape, and the clamping unit ensures that the mold stays closed under high pressure during injection. The cooling system helps solidify the molded plastic before the part is ejected. The process starts when plastic pellets are packed into the hopper. The screw rotates and pushes the pellets forward while heaters melt the material. As the plastic moves through the barrel, it becomes a homogeneous molten mass ready for injection. Once the correct amount of molten plastic is prepared, the screw moves forward like a plunger. It injects the material into the mold cavity at high pressure. The injection speed and pressure must be controlled carefully to ensure proper filling, prevent shots, and avoid burn marks or flash. After the cavity is filled, the machine applies holding pressure to compensate for material shrinkage during cooling. This step is crucial for controlling weld pack, sink marks, and overall dimensional accuracy. Once the packing stage is completed, the part remains in the mold while the cooling system removes heat from the material. Proper cooling layout is essential because uneven cooling can cause weld pack deformation or internal stress. After the part has cooled sufficiently, the mold opens and ejector pin should push the part out. At this point, the operators or robot might perform a quick inspection to ensure that the part is free from visible defects. The most important processing parameters include barrel temperature, injection speed, injection pressure, holding pressure and holding time, cooling time, screw back pressure. Any change in these parameters can affect the part's quality, including its dimensions, appearance, and mechanical properties. Some common defects in injection molding include weld pack, sink marks, weld lines, shots, flash, burns, and flow lines. Understanding the root cause of its defect is essential for troubleshooting and improving the overall process stability. Injection molding is crucial because it allows us to produce high-precision parts with complex geometry. It supports high-volume production and consistent quality, which are critical for automotive applications. By optimizing the mold design, material selection, the process parameters, we can ensure that the final product meets both functional and aesthetic requirements. That is my explanation of injection molding process. Although the concept sounds simple, achieving stable production requires experience, detailed analysis, and close collaboration between engineer, tooling, and production teams. Thank you for listening.